Example 3, we have a table with a rectangular top that's been extended with a table leaf as shown. So here's the blue part would be our original tabletop, and then the green part over here would be our leaf extension. So sometimes they have leaves in tables that make them bigger. Maybe you use those at your house if you have company over or something. You need a few more chairs and a little bit more table space. So if we look at this, it says multiply 3.5 times the quantity 6.5 plus x to write an equivalent expression for the total area of the extended table. So if we look at this, we did an extension, we still have a rectangle though. So basically what they're saying is, we know area of a rectangle, we take length times width. So we could say one of our dimensions here, this whole thing, would be like x plus 6.5. The other direction is just 3.5. Well, normally we might think of the x plus 6.5 as being our length, but when you're multiplying, does it matter what order you put the factors in?
No.
You'll still get the same answer. So we can think of it like this, but if we just switch those around, that will give us that same expression that the book had. So x plus 6.5, that quantity times 3.5. If we just rearrange the order there, then that'll be exactly what the book had, which is 3.5 times the quantity x plus 6.5. They have 6.5 plus x, but that would be the same thing. Does that make sense?
Yeah.
Okay, so what we're doing then is just writing an equivalent expression. So we're just distributing these. So we do 3.5 times 6.5, which ends up being 22.75. We do 3.5 times x, which is 3.5x. So this would be an equivalent expression to that. The question then also, they ask, what does each term tell you about the table? So if we think about this, actually we could separate it and kind of split it off. If we did the 3.5 times 6.5, if you multiply those together, you will get 22.75. So basically 22.75 square feet. That represented, like the book says, the area of the original table.
What's that saying?
22.75 square feet, sorry.
Oh.
Okay, so like the book says, that's the area of the original table. And then the 3.5 times x, if you look at our leaf here, we have an x going across, up and down, just like it is on the other side, would be also 3.5. So we multiply those together, that's the 3.5x, which is the area of our table leaf. So if we look at the try it, says the total area in square feet of rectangular stage that has been widened by x feet is represented by 1,900 plus 76x. Use the distributive property to factor the expression. So factoring we've talked about. What does each factor in the equivalent expression tell you about the stage? So factoring, we talked about, is kind of the opposite process of distributing. It's like going backwards. Undistributing, I called it jokingly. So if we look at this, here's our picture. Doesn't really tell me a whole lot. What I can do though is look at this expression here, 1,900 plus 76x, and we can think about what these two terms have in common. What factor could they both be divided by evenly? Well, if we look at our numbers, 1,976 are our two numbers. What's the biggest possible number that they could both be divided by evenly? 76 would be the biggest possible number because 76 is our smallest number. 76 divided by 76 obviously comes out evenly. The question is, if we do 1,900 divided by 76, whether that comes out evenly. So we could check that out. And what actually ends up happening is it goes in 25 times evenly. So 25 times evenly, what that means is that we could factor out a 76. And then like we did in the lesson we talked about factoring, we can think about now 76 times what to get 1,900? Well, we just did it, right? It would be 76 times 25, and then plus 76 times what to get 76x? 1x or just x, right? So that would be our factored expression. That's the first part of the question. And then the second part is what each factor tells us about the stage. Well, we know to find the area of a rectangle, like we talked about in the last problem, we do length times width. So what should happen if we did this correctly, one of these factors should be the length and one of them should be the width. So if we look at our picture, the x, or the 1x, we can see is already given to us. So it must be that this would be 25. And then our length would be 76. So if you think about this, the 76 times this all together would be 25 plus 1x, or just 25 plus x. Again, multiplying length times width to get that area. So again, the 76 we could say would represent the length of the stage, and the 25 plus 1x, the 25 was the original part, and then the plus x is our extension. So this is our width, including the extension. So look on page 240. Again, the key concept just talks about rewriting expressions and how we can write equivalent expressions. If we look at number 2 on the do you understand, the total area in square feet of rectangular mural that has been extended by x feet is represented by 5.5 times the quantity, 7.5 plus x. Expand the expression using the distributive property. What do all the terms in the equivalent expression tell you about the mural? So when they're saying expand it using the distributive property, they're basically saying go ahead and distribute, is what that's meaning. So if we do this, so we do 5.5, we do 5.5 times 7.5 plus 5.5 times x. And then we can multiply those. So if we multiply 5.5 times 7.5, we'll end up getting 41 and 25 hundredths. Obviously 5.5 times x would just be 5.5x. So once we've done that part, the next question is, what do each of the terms tell you about the mural? So If we think about this like we did previously, 41.25 would be the area of what? And then what would the 5.5x represent?
5.5x stands for the extension.
Good. So 5.5x represents the area of the extension. So if we look at number 5, a rope is used to make a fence in the shape of an equilateral triangle around a newly planted tree. The length of the rope is represented with the expression 9x plus 15. Rewrite the expression to represent the 3 side lengths of the rope fence. So there's different ways potentially we could do this. One way we could think about actually is that on our triangle we have how many sides? 3 sides. So we've got 3 sides. This is an equilateral triangle, and we know an equilateral triangle, what do we know about the sides? They're all the same. So if all 3 sides are the same, I should be able to actually factor this as 3 times something. We should have 3 sides that are identical, so our perimeter, basically, length of the rope is like our perimeter here, should be able to be 3 times something. So this is like factoring. So we're thinking about 3 times what to get 9x? Well, 3 times 3x would be 9x. And then 3 times what would be 15 would be 5. So this would be an expression that would be equivalent to that. And from that, then we would know that the length of one side would just be 3x plus 5. Workbook page 59, if we look at number 2, area of a rectangular outdoor stage has been extended on one side. The entire new area in square meters can be written as 216 plus 12x. Factor the expression to find the dimensions of the extended stage. So we know it's rectangular. We know the area of a rectangle is length times width. And this is kind of like those ones we've been doing before. So we have some rectangle and then a rectangle part's been added onto it. If we look at this problem with our 216 and our 12, 12 is the biggest possible number that we could factor out of this. So what we're going to do, we would take 216 divided by 12 and see if that comes out evenly. And it actually does. 216 divided by 12 is 18. And so this actually would be able to factor. We could factor out a 12, which would leave us with 18 plus x. So 12 is one of our dimensions. 18 plus x is our other dimension. So kind of think about like this. This was 12, this is 18, and here's our x. So that makes that 18 plus x. So this would be, we could say 12 is the width of our stage, and then 18 plus x is now our new length of our stage. So I guess technically the dimensions we could say are 12 and 18 plus x. If we look at number 4, manager of a store increases the price of a popular product by 5%. Let T be the original price. The new price is T plus 500ths T. Find an expression equivalent to T plus 500ths T. So we know in front of that first T we could put a 1. Are these like terms?
Yes.
Yes means we can combine them together. So 1T plus 500ths T would be 1 and 500ths T. Good. Okay, so that's our new price. We just found an equivalent expression for that new price. So if the original price was $24, what is the new price? We could then just take 1 and 500ths times 24. And if we work that out, we would get $25.20. Since the price increased, make sure your answer is more than 24. If it's not more than 24, we made a mistake there. Number 5, a landowner recently sold a large plot of land. The sale decreased his total acreage by 12%. Let V be the original acreage. Write 2 equivalent expressions that represent the new acreage. So one way we could think about it, we had V was our original, and then we decreased it by 12%. Well, that 12%, that's 12% of our original. So we're subtracting because it's decreasing it. 12% we could write as a decimal would be
0.12.
good. So 1200ths, and then that's 1200ths of our original acreage. So original acreage V minus 12% of V, minus 1200ths times V. That would be one equivalent expression we could do. So that's answer number 1, we could say. And then answer number 2,
Turn that to negative.
right, so since we're subtracting, if you want to here, we can add the opposite. In front of our V, we can put a 1. And then these are different signs, means we're subtracting. So if we have 1 and we take away 1200ths, we'll end up getting 8800ths. We have more positives here, so that would be 8800ths times V. So like we talked about, basically that means we have 88% of what the original was, which hopefully makes sense to you. We had 100%, we took away 12%, now we have 88% left.